A theater seats 1,000 people, and if the ticket price is $15, then the play will sell out. For each increase of $1 in the ticket price, 50 less tickets will be sold. What price should be charged in order to maximize the revenue from ticket sales? So the question is asking what price we should sell the tickets to maximize the revenue. So we need a function for revenue. So we'll call that R of X. And the revenue will be number of tickets sold times ticket price. So from the first line, we could see when there was 1,000 tickets sold, it costed $15. So we'll write that. So some other information it gave us is each increase of $1 in the ticket price, 50 less tickets will be sold. So let X be ticket increases slash decreases. So if we raise the price by $1, the ticket price is going to be 16. And from that increase of $1, 50 less tickets will be sold. So in the case that the tickets cost $16, there's going to be 950 tickets sold. So you could see if you plug in 1 for X, it'll work. So we know we got the function right. Now let's just expand. So we're going to get 15,000 plus 1,000x minus 750x minus 50x squared. And let's collect some like terms and bring the x squared to the front. So we're going to get 250x plus 15,000. So this is our revenue function. So in order to maximize revenue, we need to take the derivative and set it to 0 to find the critical points. So let's derive this. We're going to get 100x plus 250 and the constant 0. So we're going to set it equal to 0 and we're going to get 100x equals 250. So x equals 2.5. So we found that we must increase the price by $2.5. So the ticket price will be 17.5 to maximize profit. So let's do the second derivative test to make sure this is right. So it's negative 100, meaning it's going to be concave down at that point, meaning we've found the point where the revenue is maximized. So this is when x equals 2.5. So our final answer is $17.5 to maximize revenue. If we sell concert tickets at a price of $50, we can expect an attendance of 400 people. For each $5 decrease in price, another 700 tickets are sold. Expenses are incurred at $11 per ticket. Compute the ticket price that maximizes profit. So since we're trying to maximize profit, we need a function for profit. So as you know, profit equals revenue minus cost. So the question gives us that expenses are incurred at $11 per ticket. So C of X will be $11 times X, where X is tickets sold. For the revenue function, it's similar to last question. It's number of tickets sold times ticket price. So looking at the first line of the question, it says that 400 tickets are sold at a price of $50. So we could write that, leave space, and 50. And it says each decrease of $5, another 700 tickets are sold. So if we decrease it by $5, then another 700 will be sold. X is ticket increases or decreases. So we're actually going to redo this cost function. It'll make it a bit easier. So the cost will be $11 times the number of tickets sold. And from our revenue function, it's just 400 plus 700x. Now the x's in both functions mean the same thing, so we could group and expand. So let's just write it all over here. So now let's just collect like terms. So now that we have the profit function, we need to find the critical points by deriving it and setting it equal to 0. So we're going to get 7,000x plus 40,700, and we're going to set that equal to 0. And if you rearrange, you're going to get 40,700 over 7,000. So if you plug that in, you're going to get 5.81. So let's do the second derivative test to make sure this is when it maximizes profit. So you're going to get negative 7,000. So since it's concave down at this point, we know that x equals 5.81 correlates to a maximum profit. So using this formula we made for the ticket price, let's just plug in 5.81 and see what the new ticket price should be. So 50 minus 5 times 5.81, and you're going to get 20.95. So this is the new ticket price to maximize profit, $20.95, where X is given as the amount of shoes to produce in thousands. If you are restricted by the market to produce a maximum of 5,000 pairs of shoes, how many shoes do you need to produce in order to optimize your profit? So this question is asking how many shoes we need to produce to optimize the profit. So we're going to need an equation for profit. So as we know, profit equals revenue minus cost. So the cost function, it already gave it to us as x squared minus 6x plus 15, where x is number of shoes. And the revenue will just be $15 times x, which is the number of shoes sold. So let's just write that here. We're going to get 15x minus x squared minus 6x plus 15. So let's expand. We're going to get negative x squared plus 6x minus 15. And if we collect like terms, we're going to get negative x squared plus 21x minus 15. So this is our function for profit. And to find the critical points, we need to derive it and set it equal to 0. So p prime of x is equal to negative 2x plus 21. And if we set it equal to 0, we're going to get x equals 21 over 2, which is 10.5. So let's do the second derivative test to make sure this is correct. We're going to get a negative 2. So that means the function at this point, x equals 10.5, is concave down. So that means we're going to get a max, and therefore we just maximize the profit. So remember, since it says that x is in thousands, we need to multiply this by 1,000 to get the true number of shoes produced. So our final answer is 10,500 shoes in order to maximize the profit.